Hello, algebra students. Mr. Lawrence here, and we're going to do a video on the distance formula. It's pretty easy. I have it written right here, and some of you are going to look at it and go, I've never seen that before, but actually you have. Think about it. You know what the D stands for. The D stands for distance. What is x sub 1? Well, it's an x coordinate, right? And x sub 2 would be the second x coordinate. Y sub 1 would be the first y coordinate. And y sub 2, the second y coordinate. You know what a quantity is, you know what subtraction is, you know what exponents are, and you know what a square root is. You know how to do this, even if you've never seen it before. All you have to do is plug in the information. So let's do that. All right, I'm going to take 3 minus 7, and I'm going to square it. And then I'm going to add the difference of 6 and 3 and square that. Add them together and take the square roots. So when I do that, 3 minus 7 is negative 4 squared, plus 6 minus 3 is 3 squared. So then I'm going to get the square root of 16 plus 9. And notice it's very important to use those parentheses. And that'll mean I need the square root of 25. And it's plus or minus 5, but since I'm doing a distance, I'm only going to focus myself on the positive one. Now, if you didn't believe me and you were stuck and couldn't remember what to do, you could plot the 2 points. Let's see here. Let me get a graph out here. And let's see, what were the points? 3, 6, and 7, 3. So 3, 6 would be located right there. And then 7, 3, 1, 2, 3 would be right there. And remember in a previous video, we talked about finding the distance between 2 points. Well, we use the Pythagorean theorem to do it. The distance formula is really just a derivative of the Pythagorean theorem. If I wanted to, I could figure out the length of this segment, the length of that segment, and then put it into the Pythagorean theorem, right? I'm looking for x. How long is this? Well, it looks like it's 3 units. How long is that? 4 units. And so I could go a squared plus b squared equals c squared. And then, of course, a would be 3, b would be 4, c squared. And so it would be 9 plus 16 equals c squared. 25 equals c squared. And then I will take the square root of both sides and get c equals 5. Okay, so if you were stuck and the formula really intimidated you, you could plot the 2 points, make a right triangle, and use the distance formula. Yeah, when I see a problem like this one here, this is really very similar to the plane flying so many miles north and so many miles west, or the person walking. All right, let's do one more using the distance formula. And we're going to go x sub 1 and y sub 1, and x sub 2 and y sub 2. And so the distance formula is square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. And so I'm going to plug in my information, and I'm going to get the square root of 12 minus 5 squared plus negative 6 minus 8 squared. Got to follow my order of operations, so I'm going to do the subtraction and get 7 squared plus negative 14 squared, which is going to get me the square root of 49 plus 196, right? And if I take 4 away from there, I get 45, so that's going to be 245. Now I could use rads to break that down, or I'll go to my calculator because 245 is not a perfect square. And so if I wanted the square root of 245, let me clear all this out. So let me go. The square root of 245. Oops, I did it again, putting that unnecessary parenthesis in there. All right, and so it would be approximately 15 and 65 hundredths. So that's it. That's the distance formula. Real simple. Tell you what, I will put a couple on here. Just make up a couple off the top of my head, and then you can try them and check them with me at a later date. All right? Let's go -7, 12, and the point -10, 15. All right, see if you can find the distance between those 2 points. Call that problem A, and I'll do problem B. Let's go 0, 7, and -3, -9. Okay, so you can try those. Just plug them into the formula, use parentheses, follow the order of operations, and you should be okay. All right, that's it for the video. Mr. Lawrence signing off. Good night, everybody.